Hello everyone and welcome to another one of Mr. Martin's math videos. This is a video for BC Math 9. We're on chapter 6, section 2, solving equations with brackets. So far we've done one-step and two-step equations with multiplication, division, and addition, subtraction. And now we're going to learn how to solve equations with brackets. So by the end of this lesson, you should be able to explore and model problems with linear equations involving brackets on one side, and use multiple strategies to solve linear equations with rational numbers and brackets on one side. So we'll look at a couple ways of doing this. So today we're going to learn how to solve equations in the form a bracket x plus b bracket equals c. To do this, we need to use a skill called the distributive property. What is a distributive property? Well, let's say Doug has a donut bakery service called Doug's Delectable Donuts. Unlike other donut shops, Doug's Delectable Donuts hand delivers delightful donuts to your door. Don't you dare say that donut is distasteful, or else Doug and his band of donut delivery dudes will become depressed. Since the donuts are hand delivered, it is often welcome practice to tip the donut delivery dudes after they deliver the donuts. To get the biggest tip possible, Doug's delivery dudes distribute donuts to each person with a special donut box and a smile. So what does this have to do with math? That's quite a mouthful. Well, consider the following equations here, where it's 5 bracket x plus 4 bracket equals negative 25. How can you solve for x when it's stuck inside of the brackets? The key is to imagine the x in our equation as one of Doug's delivery dudes, and the x in the 4 as people to whom the delivery dudes is delivering donuts to. To get the best tips possible, 5 must be distributed itself to both the x and the 4 by multiplying with each of these terms. After we do this, we follow the rules of algebra that we learned in previous 2 lessons. Okay, I'm just going to make my cursor a little bit smaller. All right, so here's an example. We'll do this 2 different ways, okay, because sometimes we can do these more than one way. So I have 5 bracket x plus 4 equals negative 25. So first, in order for me to do some of the algebra I need to get rid of those brackets. Okay, so there's 2 ways I can do that. One is to multiply. So here what this statement is saying here, okay, is that you're multiplying 5 to the x and 5 to the 4 as well. Okay, so on this side, it becomes 5 times, it becomes 5 times x plus 5 times 4. Okay? Because that 5 is multiplied to both of the expressions inside of my bracket. All right? And that's equal to negative 25. So that gives me 5x plus 20 is equal to negative 25. And then from here, you should be able to solve these equations by now. You have minus 20 on both sides. That leaves me with 5x is equal to negative 45, which if I divide 5 on both sides, I get x is equal to negative 9. Okay? So that's distributive property. You're taking the number that you're multiplying to the binomial, and you're multiplying it to each term within the binomial. So it becomes 5 times x and 5 times 4, which gives us 5x plus 20, as we saw in the work here. Okay? Another way of doing this, all right, this problem here, 5x plus 4 is equal to negative 25. And here, I would suggest that you do this really only if the number you're multiplying on this side here is a multiple of your number on the other side of the equal sign, okay? Because in this situation, 5 and 25, 5 goes really well into 25, doesn't it? And so here, instead of multiplying this binomial by 5, I'm going to divide the equation on both sides by 5, okay? That means this is times 5 divided by 5, which cancels out. And that leaves me with x plus 4 equals negative 5, all right? And then I subtract 4 on both sides, and you end up with x is equal to negative 9. Both give you the same answer, all right? One uses the distributive property, one just uses opposite operations, okay? Now, you might be thinking to yourself, well, the second one that I showed you is way easier than the first one I showed you. Why even bother with the distributive property? Well, if this number was not a negative 25, let's say it was a negative 24 instead of a negative 25, here, by dividing both sides by 5, I would have ended up with a fraction, which I think for a lot of you guys complicates your question a lot more than it simplifies it. And so here you only kind of want to do this approach when the 5 and the 25, the number that you're multiplying in the bracket and the number on the other side of the equal side are multiples, okay, of each other, so you don't end up with a fraction. Okay, in this situation, I didn't end up with a fraction, so this situation made sense. But in every other situation where you would end up with a fraction, you're better off distributing the 5 into the x and the 4, and then doing your two-step algebra from there. Okay, let's do a couple more examples here. Okay, first I'm going to do examples by distributing, and then we'll see if we could have done the other method as well. So in this situation here again, that 2 needs to be multiplied to the x, which gives me 2x, and then needs to be multiplied to the negative 10, which gives me negative 20, okay, is equal to negative 34. And then from here, it's just two-step algebraic problem, plus 20 on both sides. 2x is equal to negative 14. And that gives me x is equal to negative 7. Okay? Now, in this example, I also want us to ask ourselves, could I have done the other approach here? Does 2 go into 34 nicely? That's the question, right? Does this 2 go into the negative 34 nicely? And the answer is yes. So in this situation, another approach I could have done is I could have divided both sides by 2. Times 2 divided by 2, they cancel out, which leaves me with x minus 10 is equal to negative 34 divided by 2 is negative 17. Okay, and then here it's plus 10, and I end up with x is equal to negative 7. Okay, both give you the same answer, two different approaches. All right, what about this one? There's no brackets here, right? Well, we talked about this a little bit 2 classes ago in our video. When you have a denominator like this, you can assume that there's brackets here in both. The brackets in the numerator and the brackets in the denominator, okay? Now, in this situation, when you're dividing a polynomial by a monomial, okay, here you just want to multiply both sides by 4. Okay, so here I'm going to multiply 4 on both sides. The times 4 divided by 4 cancel out, which leaves me with 2x minus 7 is equal to 36. And then from there, it's a two-step math problem, plus 7 plus 7. 2x is equal to, what is this, 43? 43 divided by 2, and end up with x is equal to 43 over 2. I'm just going to leave it like that. For now here, what would this be if I didn't? It would be 21 and a half. Okay, that would be the mixed fraction answer. Okay, so when your binomial is in the denominator like this, okay, just multiply the when the binomial is in the numerator like this, just multiply the denominator on both sides like we did. Okay, and that's kind of really the only approach for that question. You wouldn't want to divide both 2x and negative 7 by 4, because then you get a bunch of fractions and you'll still get the same answer, but it just complicates your question a lot. Okay, I want you to give this a try now. This is your turn. Give it a shot, and we'll go from here. Pause the video, try it on your own. All right, hopefully that went well for you. Let's take a look at some of these questions. First one here, negative 7. We're going to do both approaches here. The negative 7, I need to multiply into both the 5 and the negative x. And so negative 7 times 5 is negative 35. And then negative 7 times negative x is positive 7x is equal to negative 77. And then from there, you're just you're just doing your algebra, right? These steps here, 7x negative 77 plus 35 is negative 42. Negative 42, and then divided by 7, I get x is equal to negative 6. Okay? But again, here we could have done the other approach, because here that negative 7 goes nicely into the negative 77. Right? Here, if I divide both these sides by negative 7, that works quite nicely. The 7's cancel out on this side, leaving me with 5 minus x is equal to negative 7 divided by negative, negative 77 divided by negative 7 is positive 11. Okay, and then here minus 5 gives me negative x is equal to positive 6. And then here you can divide both sides by negative 1 to get rid of that negative sign, and you get x is equal to negative 6. Same answer, two different approaches. All right. This situation here, what we want to do is just multiply that denominator on both sides. So times 3 times 3. That's going to cancel the 3's there, leaving me with 3x minus 6 is equal to 24. And then you're just doing algebra at that point. 3x is equal to 30. Divided by 3, x is equal to 10. Done. All right. This one here, maybe we can just do the second approach for this one, because 2 goes nicely into 4.2. See that? So I'm just going to divide both sides by 2. And I end up with 2.1 is equal to e minus 0.6. And plus 0.6 plus 0.6. I end up with 2.7 is equal to e. All right. If you want to see the other distributive property, we can do it real quick here. 4.2 is equal to 2e minus 0.6. Here I distribute the 2 into both positions, so that would give me 2e, and then 2 times negative 0.6 would give me negative 1.2 is equal to 4.2, and then plus 1.2 on both sides would give me 5.4 is equal to 2e divided by 2, e is equal to 2.7. Same thing. Okay, distributive property, or just if it makes sense using the other strategy, either way works. Okay, in this situation, I'm going to avoid distributive property, because if I'm distributing a fraction, I'm giving myself more fractions to deal with. Okay, so in this situation, because it's time 2 over 3, I'm going to divide by 2 over 3 on both sides. That's a 2, promise. So that's going to cancel that out. I'm going to end up with 5 minus g on the right side. And little side calculation here, 7 over 6 divided by 2 over 3 is like saying 7 over 6 times 3 over 2, which is equal to 21 over 12. So 21 over 12. And then here I'm going to have minus 5 on both sides. And then here, so it's 21 over 12 minus 5 over 1, which is like saying I need common denominators. So 21 over 12 minus 5 times 12 is 60 over 12, which gives me negative 39 over 12. Yeah. Negative 39 over 12. So this gives me negative 39 over 12 is equal to negative g. Okay. And then you just divide both sides by negative 1 to cancel out that negative, and you get g is equal to positive 39 over 12. Or if you're doing mixed fractions, or 3 and 3/12 or 1/4. All right. So that's your answer there in improper form or in mixed fraction form. Okay, so this is a couple ways of doing it, a couple approaches. You'll have more practice in your homework assignment So make sure you're keeping up with those. Let's go on with another example here, a word problem. All right, so on a typical February day in Whitehorse, Yukon Territory, the daily average temperature is negative 13.2 degrees Celsius. The low temperature is negative 18.1 degrees Celsius. What is the high temperature? Okay, so the daily average... Okay, so you guys know how to get average, right? You add all of the scores and you divide it by the amount of scores. If I were to tell you guys, how do you average the score on 3 tests, right? You would say, okay, I got 82% on one test plus 75% on the other test plus 88% on a third test. If you want the average of those, you add them all together and you divide it by the number of terms, so 3, right? And then that would give you your test average, okay? Same situation here for temperature average here, okay? So here we would want to do, we'd add lowest temperature to highest temperature divided by 2, because there's only 2 of them, gives me my average, temperature, okay? Now in this situation here, they give us our low temperature of negative 18.1, but they don't give us the high. And they also give us the average of negative 13.2. So let me substitute those in red. Negative 18.1 plus H. Okay? Now for this situation, because I have a denominator there, I'm just going to multiply both sides of my equation by 2. That cancels out that denominator there. I end up with negative 18.1 plus H is equal to negative 26.4 degrees. And then I add 18.1 degrees on both sides. And I end up, that cancels that out. I end up with H is equal to negative 26.4 plus 18.1. The high is negative 8.3 in Yukon. The balmy 8.3 degrees for all those in Yukon. And so it's cold. It's cold. And it's February, so it's supposed to be cold in Yukon in February. It makes sense. All right. Let's try another word problem, because you're going to have obviously some calculations like this in your homework. You're also going to have word problems, so important that we get a good idea of how to solve these word problems. So let's do another example. Billy bought 4 cans of pickled beans. He had a coupon that reduced each can by 0.88, so 88 cents. If he paid $6.08 in total, what was the original price of each can? Aha. All right, so we know here that the original price, we're going to say original price is P. This is going to be P, okay? So the original price of each can was reduced by 0.88 cents, right? So the original price was reduced by 0.88, okay? Now, how many of those cans did we buy? We bought 4 cans. So that reduced price is going to be multiplied by 4, and the total price that we paid is then going to equal $6.08. Okay? So now we got to figure out, okay, what is P? Okay, well, this is a good question here, and this is a good example here where 4 doesn't really go nicely into 6.08. Okay, it just doesn't. And so in this situation, I would want to use only distributive property. Okay, I would not want to use the other method we talk about by crossing out the denominator, by dividing 4 on both sides, because I'd end up with a fraction on the right side, and that would not help my cause. That would complicate this problem. So I'm going to distribute that 4. So first the 4 times the P, which is 4P, and then the 4 times the negative 0.88. 4 times negative 0.88 gives me negative 3.52. and that's equal to $6.08. So here, what this is telling me is I've saved $3.52 with that discount 4 times each can, because this discount is applied on each can, so it has to be applied 4 times, which is what we did here. Okay, now it's just 2-step algebra. You're used to these questions by now, so I'm going to add 3.52 on both sides. That cancels that out. I'm left with 4p is equal to, that's $9.60, and then I'm going to divide by 4, and that's going to give me 9.6 divided by 4, $2.40. Now when you're dealing with money, even though here I don't have a second decimal place, you always keep 2 decimal places with money. Okay, that's just how money works. 2 decimal places. We have pennies, we have dimes, we have nickels, we have quarters. Those are all in the 2 decimal places, and then dollars obviously are in front of the decimal. Okay, so that's how you would set up that word problem. Last question here. Ooh, this is a tough one here. All right, and in this situation we have to distribute for this question. There's no way around it. So again, you're just going to take, and now you don't just take the term in the front you also take the sign in the front. So here, this is what's going to get multiplied everywhere. So negative 2 times x is negative 2x. And then negative 2 times 3 is negative 6. Okay? Same thing over here. You do it again. Negative 4 times x is negative 4x. And negative 4 times negative 5 is plus 20. And I don't have any more brackets because I've gotten rid of the brackets by distributing. Okay? You follow that, rewatch it if you need to. Okay, we're multiplying each thing. And now you're just combining like terms and doing algebra. So here I have some like terms. These 2 terms are like terms. These 2 terms are like terms. So negative 2x minus 4x is negative 6x. And negative 6 plus 20 is plus 14 is equal to 50. And then it's just a 2-step algebra problem. Minus 14 on both sides. Negative 6x is equal to, would that be 36? And then divided by negative 6 on both sides. And I get an answer of x is equal to negative 6. All right. 36 divided by negative 6 equals negative 6. Surprise, surprise. All right. So those are your notes for today. All right, hopefully they have been helpful for you. Hopefully by the end of these notes you can model problems with linear equations using brackets and on one side, okay, using word problems where you're able to figure out the equations we came up with and can you do it. And then can you use multiple strategies to solve these types of equations. We talked about using distribution to solve these kinds of equations like this. And we also talked about if the number on the other side of the equal sign, like for example, in this situation, the negative 7 goes nicely into the negative 77, then I can just divide both sides by negative 7. But I don't want to do that in a situation, there's not a lot of examples of a situation where you wouldn't want to do that. You wouldn't want to do that in a situation like this, right? Just because the 4 doesn't go, I would get a fraction here potentially, and I just don't want that. So I'm just going to use the distributive property. Okay, so those are the 2 strategies. At the bottom here is your homework. This is due Wednesday, submitted in Teams. If you have any questions, leave it in the comments or in the homework questions channel on our Teams group. And hopefully this video was helpful for you, and I'll see you next time. Goodbye.